Bayes' theorem was special. It gave humans a framework for quantifying belief. Even more so, it gave us a framework for quantifying how much belief changes with evidence. An unrestricted probability distribution is the distribution of a variable when you know nothing else but that thing. But now you learn a new thing. Does that new thing change your beliefs? We start with an unrestricted probability space for the value of a variable A. This probability distribution represents your beliefs, your predictions for this variable A. Bayes' theorem led us to ask a new question about our beliefs. It led us to ask how this probability space shifts when you take other information into account. It was a revolution. So let's take a new piece of information, B. How much can we learn about A if we know B? If our predictions for A shift quite a bit when B is taken into account, then B is good information to have, given that you want to know A. Learning is represented in the amount of shift. For probability distributions, the shift can be seen in the shape, location, or spread. All of these things have meaning. If knowing B does little to change our knowledge of A, then the conditional probability distribution of A given B will not be much different than the unconditional probability distribution of A. Imagine if we could see this shift for all our beliefs. If we could know how much our probability space has changed as a function of the evidence we have gathered. In the late 1900s, another revolution occurred. We became able to estimate this shifted space, the conditional distribution of A given B, the posterior distribution of A given B. A synergy arose from the union of two probability tools. Monte Carlo sampling can randomly select values from a probability distribution. Markov chains are a series of events where each event in the chain is wholly predicted by the event that came before it. Markov chains guide the Monte Carlo sampler to explore the conditional probability space. Together, they learn. And now that we have these little chains, we can quantify our beliefs before and our beliefs after we gain new information. Bayes' theorem led us to ask how much our beliefs changed when we considered other information. Imagine if we thought about all our research questions in this way. If we did, would our experiments be designed to confirm our beliefs, or rather to shift them? How would science progress differently if we took this perspective? Let's think about these things while focusing on your breath, the visuals, the sound, or a combination of these things. Thank you for joining me for this meditation.